here we have two pie charts given to us about a mobile company which has 6 different types of mobiles. The first pie chart talks about the distribution of the sales revenue, and the second pie chart talks about the distribution of the sales volume, which is what I have put here on the table here. These is the percentages of sales revenue of each of the models, and this is the percentages of the sales volume of each of the models. And it's given that there are 6 different models, A, K, R, M, V and Z, not necessarily in any specific order, which means we do not know which model belongs to which type of mobile here. And it is known that the selling price of R is twice that of M. The selling price of R is twice that of M, we know that, and the selling price of V and that of Z are in the ratio 2:3. Selling price of V and Z are in the ratio 2:3. The selling price of K is more than that of M. So, we know that the selling price of K is more than that of M. Now, this is the data that we have before we jump into the questions. Let us now look at question. The selling price of Z is 25% less than that of K52. The selling price of Z is 25% less than, which means it is 75% off or 3/4 of K. This is what is given to us. And then we are being asked to find out the ratio of the selling price of M and A. We need to find out the ratio of M and A. This is the question. Now, before we get into the question, we need to understand that we have some data given to us. What do we make out of the data? The question is on the selling price, and the given data is the sales revenue and the sales volume. So, from say if we know the sales revenue and we know the sales volume, you know that we can find out the selling price. Per unit price is nothing but the revenue by volume, if there is only one kind of item which is being sold, which is exactly the case here. There is only one type of mobile which is being sold in each of these variants. So, the per unit price will be the revenue divided by the volume. So, if we assume that the revenue is R, then we can say that each of these are 10R, 9R, 30R, so on and so forth. Similarly, the volumes will be 10V, 12V, 20V, so on and so forth. So, the per unit selling price of each of these items here will be 10R by 10V, right. So, which is R by V. So, let us assume R by V is K just for sake of discussion. So, the per unit selling price here will be K, where we know K is nothing but the revenue by volume. This K is different from this K, you need to keep that in mind. So, here we have a K, and here we have a 3/4 K, here we have a 3/2 K, here we get a 2/3 K, and here we get a 9/16 K. These numbers are not divisible by each other, and here we get a 4/3 K. These are the per unit selling prices that we know of each of these models, and we have some relationships which are given to us. We know that the selling price of R is twice that of M, which means by looking at these unit prices, wherever the price of one is twice of another, we can say that they can be R and M. So, let us examine these selling prices for a possible case like that. Here we have a 3/2 and we have a 3/4, which means this can be R and this can be M. Similarly, we have a 2/3 and 4/3, which means this can be R and this can be M, which means there are two cases which are possible here, where this can be R, case 1, where this can be R and this can be M. So, let us write that this can be R and this can be M. Similarly, this is twice of this, so this can be R and this can be M. So, we have two cases here, case 1 there and case 2 below here. Now, let us look at the second statement. V by Z is equal to 2/3. Now, if V by Z is equal to 2/3, we need to look at a selling price, any two selling prices here which make a ratio 2/3. You can see that 2/3 by K gives us a ratio 2/3, which means this will become, this can become V and this can become Z. Now, if this becomes V, obviously that case is not possible. So, this has to be V and this has to be Z. So, in this case it's fitting in this case. Now, let us look at any other possibility. We have a K divided by 3/2 K. Now, K divided by 2/3 K, 3/2 K will make this V and this as Z. So, if this is V, so then we have V here, and if this is Z, we can put a Z up here. So, now it leaves us with two blanks. Now, what are the two blanks? We have another relationship for those two. K is greater than M. Now, out of the remaining 2 blanks, we need to see which of them is greater than m, which we have here already. So, that will become k. Now, we have 2 blanks here in the first case is 3/4 and 9/16, whereas m is 2/3. Now, 2/3 is more than 9/16, which means this cannot become k. So, this has to become k, because 0.75 is more than 0.66, which is 2/3, which is the value of m. So, this has to become k. So, that means this will become a. Similarly, for the second case, we have 9/16 and 4/3 left. We need to compare these two with the value of m, which is 3/4. Now, 3/4 and this is 4/3. Now, this has to become k, because the k's value is more than m's value. So, this will become k and this will become a. Let us now look at the question here. We have what is the ratio of the selling price of m to that of a. Selling price of m to that of a, given that the price of z is 25% less than k. Now, z has to be 25% less than k. Now, we have 2 cases, in which case we need to take will come from this statement, z is 25% less than k. Now, let us compare the first case, z and k, z and k. Now, z is actually double that of k here, because k is 0.75 and here it is 1.5, which means the first case is ruled out. We need to now look at the second case, where z and k, z is 1 and k is 1.33, which means this is 25% less than this, which means we need to take the second case. So, in the second case, the question is what is the ratio of the selling price of m and a. So, in the second case, m and a is 3/4 and 9/16. So, the ratio that we need will be 3/4 divided by 9/16. So, you know it will be 4/3. If the selling price of V is 1200 more than that of k, selling price of V is 1200 more than that of k, then what is the selling price of A? Now, it is given that V minus k is equal to 1200. Now, we know what V and k are. We have 2 cases. In case 1, V is k and k is 3/4 k. In case 2, V is 2/3 k and k is 4/3 k. That means that the case 2 is ruled out, because V is more than k, which means we need to go with case 1, and in case 1 we know V minus k is 1200, which means that k minus 3/4 k is 1200. K minus 3/4 k. You need to understand that this k here is for the mobile, and this k here is the r by v that we have taken earlier at the beginning of the set. Now, this is 1200. So, which means 1/4 k is 1200, which means k becomes 4800. The value of k is 4800. Now, we need to find out the selling price of A. The selling price of A in the first case here is 9/16 k. So, that is 9/16 into 4800, you know, is 2700. If the sales value is highest for R with its selling price as 18,000. Now, sales value has to be the highest for R. Now, which model has the sales value as the highest? As you can see from the pie chart, the music version, which is 30%, has to be the one with the highest sales value. Now, which is given as R, which means case 1 is ruled out. We need to look at case 2. Now, if we look at case 2, it is given that the selling price of R is 18,000, which means 3/2 k is 18,000, which means we can find out the value of k. And if we can find out the value of k, we need to find out the difference between the selling price of k and z. Now, in case 2, the difference between the selling price of k and z are, z is k and k is 4/3 k, which means 1/3 k is what we need to find out. We need to find out value of 1/3 k. Now, we know from this that k is 12,000 and we need the value of 1/3 k, because 4/3 k minus k is what we need. Therefore, 1/3 k will be 4,000. Which of the following statements is definitely true? The sales value of M is the highest. Now, can the sales value of M be highest? No, we just discussed in the earlier question that the sales value very clearly from the pie chart is highest for the music version. And can M be the music version? M cannot be the music version. Music version can either be Z or R. So, statement 1 can never be true. Statement 2, the sales value of V is more than that of R. The sales value of V is more than that of R. Let us examine the case 1. V is K and R is 4/3 K. But we do not need to examine the unit selling prices, we need to examine the sales values. So, what is V? V is in this case the camera version and R is the WLAN version, and we know for the camera version is 10% and WLAN is 28. So, if we take case 1, statement 2 will be false. Let us take case 2. Case 2 we again look at V and R. In case 2 V is 14 and R is 30. So, even in case 2 V is not more than that of R. So, statement 2 will have to be false. Statement 3, the sales value of Z is the least. The sales value of Z is 30 here in case 1 and 10 in case 2. Now, even in case 1 or case 2 the sales value of Z cannot be the least because we have 9s here. So, statement 3 cannot be true. Now, that leaves D as the obvious answer for this question, but let us go ahead and examine the statement. Sales value of R is more than that of K. Sales value of R, let us take the first case, R is 38 and K is 9. So, it is satisfying in case 1. Let us look at case 2, R and K, R is 30 and K is 28, it is satisfying in case 2 as well. So, this very clearly tells us that this set is one of the easiest sets that you can come across. Simple basic logic that is required, particularly at the initial stage when you arrive at the unit prices. So, once you do that and you arrive at these two cases, solving the questions is a cakewalk.